Hello, statisticians. Today's lesson is going to focus on describing a categorical variable. Let's jump in. According to Western astrology, you are assigned a zodiac sign or a star sign based on the month in which you were born. Each sign is believed to be associated with different personal traits. For example, if you're a Taurus, meaning you were born in late April or early May, you're predicted to be reliable, but also maybe sometimes stubborn. If you are a Gemini, meaning you were born in late May or early June, you're predicted to be curious, but maybe sometimes inconsistent, and so on. Think about the trait associated with your sign. Is it a good fit? Many people are skeptical about the personality traits made by astrology. However, some of the predictions are pretty good, especially for athleticism. In fact, there's a fascinating phenomenon that we call the astrological law of sports. This law states that people with astrological signs of Capricorn through Gemini, or in other words, people born in the first half of the year, tend to dominate the sporting world. So here are just a few examples. From 1896 to 2018, Capricorns and Aquarii, people born mainly in January and February, won more Olympic medals than any other group. And in 2024, 5 of 6 most common birth months for Canadian NHL players were January through May. In 2011, among nationally selected German youth tennis players, the number of January through June birthdays more than doubled the rest of the year. And as we've seen in many other sports areas such as soccer, handball, rugby, track, skiing, and more, this is a similar pattern. So that brings us to our key question for this lesson. Why are more elite athletes represented in the first half of the year? We'll keep that question in mind as we go into our notes. We're going to discuss 4 topics today, starting with frequency and relative frequency. We're going to start with exploring athletes' birthdays by looking at an example from soccer. Specifically, a group of researchers in Europe and the United States decided to gather data on the birthdays of professional Italian soccer players from 2007 through 2014. They found that 507 players had birthdays in the first quarter, or Q1 of the year, which spans January through March. 534 of the players had birthdays in Q2, April through June. 389 players had birthdays in Q3. 273 had birthdays in Q4. If we add these all together, we get a total sample size of 1,703 total soccer players. This is the total number of professional Italian soccer players that played from 2007 through 2014. This table is known as a frequency table. Frequency tables show the frequencies or raw counts in each category of a categorical variable. In this case, the categorical variable is birth quarter. And we know that birth quarter is categorical because the data takes on the form of counts within each category label of Q1, Q2, Q3, and Q4. Now, to get a sense of the relative size of each of these groups, we can calculate relative frequencies or proportions. To calculate relative frequencies, we have to divide. We're going to take each category, we're going to take the count and divide by the total. So we're going to do 507 divided by 1,703, and that is going to give us 0.298 for Q1, or 29.8% of all of the Italian soccer players were born in the first quarter of the year. And then we will continue this for the remaining quarters. So about 31.4% of the players were born in the second quarter, 22.8% of the players were born in the third quarter, and about 16% of the players were born in the fourth quarter. A way for you to check that you've done all of this work correctly is to make sure that the proportions add up to 1. In this case, they do. This new table is known as a relative frequency table. It shows the relative frequencies or proportions in each category of the categorical value. Note that we also can move the decimal over 2 places to convert all of the proportions into percentages. When we do this, the values add up to 100% instead of 1. Now, something really pops out here nicely, which is that if we look at the first 2 quarters, the first half of the year, it's easier to see that this adds up to 61.2%, much more than 50%, than half of all the players. That's pretty striking. And that's going to be more visible when we move on to our next topic, graphing bar charts. Here we have a bar chart of the frequencies that we showed earlier. The heights of the bar charts show the frequency in each category. Take a look at what's labeled in the chart to make it understandable. The title lets you know what it's all about. The axes identify the variables, and the scales make it possible to interpret what you're seeing. When you create a bar chart, make sure you help the reader to understand the data by including all of these labels. You can also choose to make a bar chart with relative frequencies. The shape doesn't change, but the y-axis is now labeled with relative frequency, and the scale shows percentages instead of counts. Now that we've displayed our data as a graph, you can really see this stark difference that shows the difference between the first 2 quarters and the second 2 quarters of the year. For example, the number of professional soccer players born between April and June is 15.4 percentage points higher than the number born between October and December. Another way to display categorical data is through pie charts. Here's a pie chart of the data that we've been looking at with relative frequencies. The area of each slice of the pie corresponds to the relative size of the category. We're not going to create a lot of pie charts in this course, but since we see them in publications pretty frequently, it's important to know what we're looking at and how to interpret it. So, just as before, we'll see how to label everything appropriately. It's not quite the same, but you'll see the same pieces. You'll see the title, the label, and the key to make sure that we understand what we are seeing here. As we did with relative frequency table, we can also check that all of the frequencies add up to 100%. Sometimes you may encounter pie charts in the news or social media elsewhere where they do not add up to 100%. Often these charts are meant to be misleading. It's worth checking the totals. This pie chart looks pretty good, and that's because our data is a good fit for a pie chart. We've got one variable, we've only got a few categories, we've got a complete set of data, and we don't have any values that are 0%. These are all things that are a good fit for a pie chart. Here's an example of a set of data that's not a good fit for a pie chart. It's got too many categories. We've got some data that has 0%. For example, 1 to 3 days, we've got 0% of people that have that level of absenteeism. So they're not all good data makes a good pie chart. And you want to be on the lookout for that as well. Finally, let's move on to comparing 2 sets of data. So we'll go back to the soccer data. In addition to collecting data on birth dates of soccer players, we also have data on all Italians from 1965 to 1995. And we'll compare that to the soccer players. So here we see relative frequency bar graphs. On the left, we have the birth rates for the entire population of Italy, and on the right, we have the birth frequencies by quarter among just the professional soccer players. And a few trends stand out. First, we see that 22.5% of all Italians are born in Q1 and 25% were born in Q2. However, those rates are much higher among the professional Italian soccer players, 29.8% and 31.4% born in Q1 and Q2 respectively. By contrast, in the general population of Italians are much higher in the second half of the year, compared to only 26.8% in Q4, to 16% in Q4 for the professional soccer players. When asked to compare frequencies or relative frequencies between groups, you can summarize our findings like this. First, we can describe any trends we see. Here we could say something along the lines of professional soccer players born in late months is lower than in the general population, which is a statement about the general trends we find between the graphs and the tables. Then we can support our statement by making specific comparisons of proportions. We can say that, for example, the proportion of soccer players born in Q4 is 16%, which is much lower than the general population of 26.8%. Note, this statement compares those two specific proportions, 16% to 26.8%, and it uses comparative language, pointing out that the proportion is lower among soccer players than the general population. When making comparisons, it's important to use comparative language such as higher, lower, or similar. So let's come back to our discussion question. We want to know, are elite athletes more likely to be born in January through June? So we've seen this trend in soccer, and we've discussed it for other athletes as well. So as you're thinking about this, I want you to think about a possible explanation, and here's a hint. Just like many other youth leagues, Italian soccer players are organized by birth year. So for example, everyone born in 2015 would be placed into the same group. Think about how grouping athletes based on this trend would play out. Take a moment to jot down your ideas and then discuss it with a partner further and be ready to share your ideas. That's it for today, statisticians. We'll see you next time.